somewhere between the Ordovician and Silurian periods. The early jawed fish evolved and diversified into several lineages, including, by the end of the Silurian, the osteichthyans, which would lead to all bony fish and vertebrates on land. However, since many fossils are known from fragments, or for example with cartilaginous fish or acanthodians, as some of the soft tissues and some of the cartilages aren't preserved, reconstructing the order of these groups is difficult, and there are alternate hypotheses. Traditionally, it has been thought that placoderms are the most primitive jawed fish, followed by cartilaginous fish, followed by acanthodians, which are shark-like but which have bones, and then finally by the osteichthyan bony fish. However, as more and more fossils are discovered, the place of these various groups is sometimes questioned, and many recent publications suggest that acanthodians and cartilaginous fish are more closely related to each other than to bony fish, so thus not a sequence of fish groups. And even that acanthodians represent the earliest stem chondrichthyans, from which then the group which will lead to sharks, rays, and chimeras evolved. So for example, Ozarchus is a cartilaginous fish estimated about 325 million years old. And as you can see, its gill arch skeleton is more similar to the early bony fish than to later acanthodians and later cartilaginous fish. This suggests then that what we associate with cartilaginous fish or acanthodians, many of these traits actually evolved over time, and that the first members of these groups, the stem lineages, would actually be more similar to placoderms and early bony fish. As an example of some of the difficulties in classifying based on anatomical traits, consider teeth. So placoderms, the earliest jawed fish, lack teeth. They simply have sharp bones in the oral area. Teeth are made of enamel and dentin, but these are also present in the scales of some bony fish alive today, and certainly sharks, which have a type of scale known as a placoid scale. It is thought that placoid scales near the mouth evolved into teeth. And so fish would have had little bumps of enamel and dentin before these actually then became teeth. But even as sharp scales, they could have had some role in securing prey in the mouth. So consider Gladbacchus, which is a stem chondrichthyan from the Middle Devonian. It was originally classified as being toothless. There are these little pieces of enamel and dentin on the mandible, but they are the size of scales. Also, in addition to being on the mandible, they are also present on the gill arches and on the roof of the mouth, the neurocranium. And so before there were these large teeth, which serve the function that we think of today, and before they looked like shark teeth, there were simply scales with enamel which could help grab prey. And these scales could be on the jaws, on the roof of the mouth, or on the gills. Gladbacchus then seems to be a stem chondrichthyan, which doesn't have the advanced features of the later acanthodians or the later sharks, but seems to be close to the base of this lineage.